Welcome. So we're going to do one more problem using the converse of triangle proportionality theorem. We want to find the value of x so that BC is parallel to ED. Right? So the only way that's going to be true is if our segments are in proportion. So if CD to DA is equal to BE to EA, then BC would be, that looks icky, BC would be parallel to ED. I got a little glitch there. Oh, and I just extended the board. Sorry about that. Using the converse of triangle, we'll abbreviate, proportionality theorem. All right, so if CD to DA is equal to BE to EA, right, then our lines are going to be parallel. All right, so let's set that up so that our proportion is equal. CD is x minus 4, DA is 18, BE is x minus 5, EA is 15. Right, so we can reduce along the denominators. Right, so 3 divides into 18 6 times, 3 divides into 15 5 times, and now we'll cross multiply. So 5 times x minus 4 equals 6 times x minus 5. When we distribute, we have 5x minus 20 equals 6x minus 30. We need to combine like terms on one side, so we'll subtract 5x from both sides. So we have negative 20 equals x minus 30, and then to solve for x, we'll add 30 to both sides. So that makes x equal to 10. So if, and so here's our final answer. All right, so we had a part A and a part B. So if x equals 10, then BC is parallel to ED. Since we're asked what value of x makes the lines parallel, we should answer that completely. All right. So now that we've looked at, I guess I should match them all up so you can see that. So now that we've looked at triangle proportionality theorem and the converse of triangle proportionality theorem, let's look at something that relates very much to those two concepts. All right, so recall that the distance between two parallel lines is always equal, right, because they are the same distance apart. When you measure distance, you measure along a perpendicular line. Right? Distance is perpendicular to the point or the line that you're measuring from. Right? If CD and EF are not perpendicular to lines M and line P, then they're not distances anymore. Right? So the distance between two parallel lines is equal. But what if we don't if we aren't measuring along a perpendicular distance? So what if the distance is not perpendicular? Right? We're not measuring a line that's perpendicular to our parallel lines. Instead, and I don't know what happened to my parallel markings, but we'll just add them. Instead, we're measuring along a line that's diagonal. Right? So if we're measuring along a diagonal line, are these lengths equal? Well, I will tell you they're not. So AB is not going to be equal to DE if they're not perpendicular to our parallel lines, and that means they'd be parallel to each other. And CD, or BC, does not equal, BC does, which one did I do? AB does not equal DE, and BC does not equal EF. But there is a relationship between these segments. so just like a parallel line, when they intersect the sides of a triangle, they divide those sides proportionately. The same thing occurs when we have parallel lines that divide any pair of lines. They're going to divide them proportionally. Right? So if we have parallel lines, those parallel lines will divide any pair of lines proportionately. And that's called the two transversal proportionality. And the reason it's called two transversals is because that a line that intersects a parallel line is called a transversal. So these lines here are parallel. Let's put some parallel markings. So if three or more parallel lines, so it does take three lines. If you only have two lines, then you're not going to have four segments. You're only going to have two segments. So if three or more parallel lines intersect two transversals, they divide the transversals proportionately. So that means that AC to CE is going to be divided in the same proportion as BD to DF. You set this up exactly the same way as you did with the triangle proportionality theorem. Right? We're going to have one line in one fraction. We're going to have the second line in the second fraction. Instead of one line, let me make that first line. Right? And they're going to be matched up so the segments opposite are across. Right? So that means that UW to WY is going to equal VX to XY. Right? So notice we went down one line for one fraction, we went down a second line for the other fraction, and we matched up the ones that were across. Right? And that's all you have to do. It's just like triangle proportionality theorem. Because technically, if we were to continue these transversals, eventually they would intersect and we would have a triangle. But we don't need to. Right? They'll be solved just the same way, whether the lines intersect or not. So in our diagram here, angle 1 is congruent to angle 2 is congruent to angle 3. Now, why is that important? Well, the only way you can use two transversal proportionality theorem is if the lines are parallel. We're not given that the lines are parallel, but we're given something that tells us the lines are parallel. So notice that angle 1, angle 2, and angle 3 are in the same relative position on the line. They're both under a line, under one of those lines, and to the right of our transversal here. So since, actually, let me put a sentence in first. Angle 1, angle 2, and angle 3 are corresponding angles. Right? Based on their position, they're corresponding angles. They're to be called corresponding angles whether or not the lines are parallel, because they're in the same relative position. So since not only are they corresponding angles, but they're congruent, since the corresponding angles are congruent, let's label these as something. It'll be easier. I don't have to keep writing. I guess I could write line PS. We won't label them. So since the corresponding angles are congruent, line PS is parallel to line QT is, whoa, that is lovely. QT is parallel to line RU. Right? So close enough. I think there's a glitch in the middle of the board. So put these in your notes. By the way, you should also have written the information that was on the last slide, but you'll put this one in your notes. All right, so now that we've established the fact that they're parallel, now we can use the two transversal proportionality theorem. So therefore, two transversal, let's abbreviate proportionality, prop theorem holds. All right, so now we can solve. All right, so this to this, 9 to 15, is going to be in the same proportion as 11, oops, let me write it as the segments, excuse me. Shame on me, not writing out the segments. PQ to QR. I'm trying not to rush, but I have to be somewhere. So PQ to QR is in the same proportion as ST to TU. Let's label that with an X. Now, let's plug in the values. All right, so PQ is 9, QR is 15, ST is 11, and TU is X. All right, so notice this was the side that I marked in green, and this is the side I marked in red. I meant to change colors, but sometimes I forget. We can do one little bit of reducing. We could divide those by 3, and that would be 3 over 5. Now we cross multiply. So we have 3x equals 11 times 5. That means 3x is 55. Let's just leave it as the exact answer. X is 55 thirds. And there we go. One done. All right, so you set these up just like triangle proportionality theorem. Let's do another one. All right, so here we're solving for, and I forgot to erase. I thought I erased. We're solving for some missing parts. All right, so suppose the artist decided to make a larger sketch of the trees shown below. In the figure, if AB is equal to 4.5 inches, BC is equal to 2.6 inches, CD is equal to 4.1 inches, and KL is equal to 4.9 inches, find LM and MN to the nearest tenth of an inch. Now we're given right here, and this is in your notes, we're given that AK is parallel to BL, is parallel to CM, is parallel to DN, which is good because that means that we can solve using two transversal proportionality theorem. All right, so here we've got 4 lines, right, which means we've got 3 different pairs. Right? You can only solve for 2 at a time. Right, so you can only use 2 segments. You can only use 2 segments on the line, and you have to use the segments across for them. So notice there's only one pair that we know both parts. Right, so AB is across from KL. That's the only pair that we know both of. So notice I've got AB and KL in both solving for, here we'll be solving for LM. And in the second fraction over here, right, we'll be solving for MN. Notice again, I've got AB and KL, right, because those are the ones we know. All right, so we match them up. I've got them already color-coded because I forgot to erase. So notice that AB and CD, I'm going to use AB and, let me erase these. I'll leave the numbers up there. But I've got both, looks like I probably erased from one problem to the next. So let's solve, first of all, for LM, for the one I labeled as X. All right, so LM and KL are going to be used, right, because we know KL, and we're looking for LM, and then we have to go across. And I almost wrote in red, which is really, green, which is really not going to work on green. So opposite LM, we have BC, and opposite KL, we have AB. So those are going to be the 4 parts we use to solve for X. All right, and so we have AB, which is 4.5, and BC, which is 2.6. That's one line. And then the segments we're using on the other line, KL is 4.9. Oops, I meant to write it in purple. I'm trying to, actually, I'll use blue, since I use little blue lines to mark them. And LM is X. Now, I don't really like to work with decimals all that much, so what I like to do is just multiply everybody by 10. So long as I do that to everybody, right, the fraction will still balance. because multiplying by 10 over 10 is the same as multiplying by 1. It just gets rid of those decimals. So now this would be 45 over 26, and this would be 49 over 10x. Right? There's not a whole lot of reducing we can do here. I might have reduced the 26 and the 10, but really isn't hardly worth the effort since it's pretty easy to multiply by 10. So I guess we'll just leave like that and cross multiply. So 10 times 45 is going to be 450x. And then I'm going to grab a calculator real quick. 49 times 26 is not 234. 49 times 26, I must have missed a digit. Well, I had to pick like the worst calculator possible. 45 times, I've hit this 3 times already. Try that again. 49 times 26 equals, there, 1274. Kept leaving off digits. All right, so now I just divide that by 450. And x is equal to, well, we will use a decimal equivalent for this. I got, because it says round to the nearest tenth of an inch, so I got 2.83111111. So that would round to 2.8. All right, so our x here is 2.8, rounded to the nearest tenth of an inch. Now you can't use LM to solve for our other missing one, MN, because we rounded, right? We rounded. LM is approximately 2.8, right? And so if you use a rounded value and solve with that, you're going to introduce rounding error. So never use a number that you've rounded, right? But LM here is about 2.8 to the nearest tenth anyway. And so now let's solve for our other missing side. So again, we'll use KL, but this time we're going to use MN, right? Because that's the other one we're missing. So we'll use this one. We're still going to use KL, but now we're going to use MN so we can solve for MN. Since we're using KL, we have to use AB again. And now we're going to use CD. So we're going to use those four. Right? So you're always going to use 2 segments on each line, and they're always going to be matched up for the ones across. All right, so we've got, again, we've got 4.5 and 2.6. And now we've got 4.1. Wait, am I using the right one? Did I grab the 4.5 and, oops, sorry. AB and CD, sorry. I accidentally grabbed BC again. We're using, actually, I'm looking at those little yellow arrows. And so now we're not using this one, we're using this one. So I'm going to draw little 2 arrows here. We're using those 2 so I don't accidentally grab the wrong number. All right, let's try that again. Now, granted, I have it written right here, but every time I move, my shadow blocks it. So AB and CD, because we want to solve for MN. All right, so we have 4.5 and 4.1, not the 2.6, is equal to, and now we'll use KL because it's opposite AB. So that's 4.9. And opposite our 4.1 is what we're looking for, the Y. Again, we can multiply by 10 to get rid of the decimals. So we'd have, I'm going to write in green, 45 divided by 41 equals 49 divided by Y. All right, and so now we have no reducing we can do. We'll cross multiply, and I'll be using a calculator here. Oops, excuse me. Equals 10y. All right, because we multiplied everybody by 10. I'm going to write that in so I don't forget. Now, if you don't multiply by 10 and you leave it as decimals, you can still solve that. I just kind of like not having to worry about the decimals. All right, so now we've got 450y equals whatever 49 times 41 is. And let's see if this calculator wants to cooperate. Now, it is a solar calculator, and so that I can see the board better, I do turn off the light. So maybe that's why it's mad at me. All right, so 49, actually I'm going to write that in, 49 times 41, those are the numbers we're multiplying. And that gives us 2009. So now we'll divide both sides by 450, which I can't fit in here anymore. You know what, I'll just extend the page just a little bit. So we'll divide both sides by 450, nice big numbers here. And y is going to be equal to 4.4, so it's 4.46, so that's going to round up, so because it's set to the nearest tenth. So 4.45. Excuse me, 4.5, right? Because the 4 will round up. So I got 4.46, right? So that makes that round up. So 4.5. And by the way, we should have included that these were inches. Right? So that means that MN is 4.5 inches. And there we go. I think I'm going to stop this podcast now, and then I'll finish up on the next podcast. So let's see how many problems we have left. And by the way, if you have any questions about this particular problem, let me know in class. But we'll look at this one, this one, this one, and this one, and this one, and this one. So we got 7 more problems. So maybe this is going to be all going to be on a podcast, or maybe we'll finish up part of this in class. Let's see how long it takes me to do a recording, and then we'll find out. But thank you for watching this one, and watch me in the next one. Bye for now.